In this video, we're going to review how to find the values of the 6 trig functions using the unit circle. So you may remember from earlier in the semester that SOHCAHTOA is how we remember the ratios of the 3 main trig functions, and we also have the reciprocal functions, the cosecant, the secant, and the cotangent. So the sine is going to be the opposite side over the hypotenuse. The cosine is the adjacent side over the hypotenuse, and the tangent is the opposite side over the adjacent side. So let's pretend that we draw an angle in here. We're just going to draw it right over here to 45 degrees, or in other words, pi over 4 radians. So if we have this angle here, and we want to imagine the 6 trig functions, we're going to picture a triangle drawn straight down here like this, where I know that this is going to end up being an isosceles right triangle, so this is going to be 45 degrees, this here is 45 degrees, and this down here would be 90 degrees. And so we're always going to refer back to our reference angle. That's going to be this angle right here, the 45 degrees near the origin, and that's where we're going to call theta. So this angle here is always theta. So the sine of theta, in this case, or the sine of pi over 4, 45 degrees, we're going to do it in radians. So the sine of pi over 4 is going to equal the opposite side over the hypotenuse. Now remember, in the unit circle, the hypotenuse is the same as the radius, and the radius is 1. So this side over here is going to have to be 1 divided by root 2, which when we rationalize becomes root 2 over 2. Alright, and the sine is going to be this distance here, the opposite side. So that's always going to give us these red numbers you see around, or the y values on the coordinate plane. The cosine is simply going to give us the x value over here. It's going to be the adjacent side over the hypotenuse, which would be 1 divided by root 2. Or after we rationalize, the cosine of pi over 4 is just going to equal also root 2 over 2. Well, the tangent of pi over 4 is going to equal the opposite side over the adjacent side, or in other words, the sine of pi over 4 divided by the cosine of pi over 4, and since they were both the same, it's going to be root 2 over 2 divided by root 2 over 2, and that's just going to come out to be 1. Now to find the reciprocal functions, we're going to say for the sine, the reciprocal is the cosecant. Remember that the cosecant does not go to the cosine as you might think. The secant does not go to the sine as you might think. They're switched. So the cosecant of pi over 4, remember the sine was 1 over root 2, or in other words, if we flip this here and we go 2 over root 2 and then we rationalize, this is simply going to come out to be the square root of 2. Alright, it would be root 2 over 1. The secant, because the cosine and the sine are the same, so when I take the reciprocal over here, it's still the same. So the secant of pi over 4 is also going to be root 2. And then you can probably guess that the cotangent of pi over 4 is also going to equal 1, because it's just going to be the cosecant over the secant, or in other words, the cosine over the sine is the reciprocal here. This is also just going to come out to be 1. Let's say we try a more difficult value where perhaps the numbers don't come out quite as nice, where the sine and the cosine aren't exactly the same. So I'm just going to erase this real quick, and we'll erase this, and we're going to move our angle in standard position. We're going to move this down here to 5 pi over 6 radians. So if you'd like to pause the video right now and try to come up with this on your own, that's a good idea. And we're going to move this over here to where we can create our same triangle. And again, even though our angle, our theta, is this here, this is theta, and theta is equal to 5 pi over 6 radians, the reference angle we're using is this angle right here, which is going to be pi over 6, in other words 30 degrees. So I know that this here is going to be 1 unit long, and if that's going to be 1 unit long, then the side opposite 30 has to be half of that, so this is going to be 1/2 of that. And then the side opposite 60 has got to be 1/2 times root 3, or in other words, root 3 over 2. So you can see this is where the x value and the y value in this point right here came from. So we go back to our sine, and again we're taking the sine of 5 pi over 6, and that's going to equal our y value here. That's going to be a positive 1/2. Positive 1/2 over a positive 1 is just going to equal 1/2. Well, the cosecant, which is the reciprocal of the sine of 5 pi over 6, is just going to be the reciprocal here, and that's just going to come out to be 2 over 1, in other words, positive 2. For the cosine of 5 pi over 6, well, the cosine was this value right here, but remember, we're in the second quadrant now. So because our angle rotated past 90 degrees into the second quadrant, this x value here is actually going to be negative. That's why it comes out to be a negative root 3 over 2. So the cosine of 5 pi over 6 is going to equal a negative root 3 over 2. The secant, which is going to be the reciprocal, so the secant of 5 pi over 6, reciprocal of the cosine, is going to equal 2 over root 3. And again, it's going to be negative, so it's negative 2 over root 3. And when we rationalize that, we're going to get a negative 2 root 3 over 3. So the secant becomes a little bit more difficult in this case here. Now the tangent of 5 pi over 6 is going to equal, okay, and it's going to be, again, the opposite side over the adjacent, or in other words, the sine over the cosine. So the sine over the cosine. So that's going to be 1/2 divided by a negative root 3 over 2. And if we're dividing by a fraction, really we're just going to multiply by the reciprocal. So we end up with 1/2 times negative 2 over root 3. And then the 2's will cancel. So I get a negative 1 over root 3, which then needs to be rationalized. So times root 3 over root 3 is going to give us a negative root 3 over 3. So the tangent of 5 pi over 6, again, a little bit more complicated to solve now, becomes out to be a negative root 3 over 3. Well, the cotangent of 5 pi over 6, again, is going to be the reciprocal of the tangent. The tangent was the sine over the cosine, so the cotangent must be the cosine over the sine. So that's going to end up being a negative root 3 over 2 divided by 1/2. And again, we're going to multiply by the reciprocal, negative root 3 over 2 times 2 over 1. The 2's cancel, and we're just going to get a negative root 3 over 1, or in other words, a negative root 3. So the cotangent of 5 pi over 6 just comes out to be a negative root 3. So this is how you can use the unit circle to help you find some of these more common trig functions at the various spots around using your special right triangles. I hope this video helped. I'll see you next time.